here's part 3. Here's my function. I'm going to start by factoring. So x minus 7 over x plus 5 times x minus 5. So I get that my domain is all real numbers except that x cannot equal plus or minus 5. I do not have a common factor in the numerator and denominator, so I do not have any holes. Roots, I only have 1, and it is at 7. Vertical asymptotes, I have x equals negative 5 and x equals 5. Tangency and togetherness, I do not have a squared effect. Now, this is not what we mean by squared. It would mean a factor that would be squared. So like if this was x plus 5 squared, then I would have some togetherness. But I don't have either one here, so this is none. Horizontal asymptote, it is bottom heavy, so that is y equals 0, which means there is none for the slant asymptote. Y-intercept, I plug 0 in. It's easier to look at this one. This is going to give me 0 and then positive 7/25. On my number line, I'm going to put my roots and my asymptotes. So negative 5, positive 5, and positive 7. So then if I plug in a negative 6, then that's going to give me negative, 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 which is overall negative. If I substitute in the 0, then I'm going to get negative, positive, negative, which is overall positive. Substitute in a 6, I get negative, positive, positive, overall negative. 8 is going to give me positive, positive, positive. Use this to check yourself too when you're over here. I mean, if things don't jive and it doesn't make sense, I mean, there's a possibility you made some mistake here. So that's when you want to take into account everything else that's going on. All right. So my asymptote. I've got one at x equals negative 5. So 1, 2, 3, 4, 5. There. And positive 5. 5. And then I have a horizontal asymptote at y equals 0. Okay, so then I can plot my root. I have one at 7, so here's one at 7. And I have one, oh, that's the only root I have, but I have a y-intercept at 0, 7/25. So it's not very much, it's like right there. That's all I got. Okay. I don't have anything on the left-hand side over here, but I can substitute in maybe a negative 6 and see what happens. So do my xy, negative 6, so that's going to give me a negative 13, and then negative 1 times negative 11, so it's kind of yucky. It's going to be negative 13 over 11, so negative 13/11. But you know what that tells me? That tells me it's a little bit more or less actually than negative 1. So if I go to negative 6, negative 1 and 2/11, so good enough right there. And so I have a point in each one, and that's really all I have to have. Would be nice to have some more every now and then, so let's just think about what's happening. From negative infinity to negative 5, which is this asymptote, it's negative the whole time. So it's going to have to look like this. Oh, let go through the point. And so I know that we've had to do a lot of graphs, I've given you a lot of graphs, but the more you do it, the more comfortable you become with just knowing that's what's going to happen. This middle part with just this one point, well, I know from negative 5 to positive 5, I'm positive the whole time. But I don't know if it's like skinny or if it's fat or what else is happening, so I'm going to come back to that. Let me see if maybe I can feel okay about this one. So from negative 5 to 7 it is negative. I'm sorry, not negative 5. From positive 5 to 7, it's negative. And remember, there's no togetherness, so I know that I'm starting up here and up here, so this has to come from down here. So it's negative to right here. Then it's positive. But it's not going to be positive and go up like this because I have this horizontal asymptote, right? My end behavior, it doesn't follow a slant asymptote, and it doesn't follow anything else. So it's going to have to come up, but it's going to have to come back and hug this. So this is one of those cases where it clearly crosses the asymptote. You know it does because the point is on it, and then you have to decide if it's going to stay on top or bottom. Well, since it's not negative all the way to negative infinity, it's positive, you know it has to be on top of it. So it's going to come up like this. Ugh. One of these days I'll actually hit it first. Like this, and then it comes back down, but it's going to get closer and closer to 0 as it goes. Alright, so now I have the middle to deal with. Thinking I might like a couple of points just to get me an idea of what's happening here. So maybe I pick a, let's see, where am I going? A negative 5. Maybe I pick negative 2 and see where I am. So I'm going to pick a negative 2. If I plug in a negative 2, then I'll kind of do my work up here, so I have a place to do it and I don't have to scroll. If I plug in a negative 2, it's going to give me negative 9 over 3 times a negative 7. So it's going to give me a positive 9 over 21. That's not even at a half. So that's, I mean, we don't have to know exactly what the decimal is. It doesn't matter. All you need to know, you should know enough about fractions and stuff that we're not even at a half yet. So when I go to negative 2, I'm still pretty low down here, right? So if I plug in a positive 2, I'm going to get negative 5 over, okay, so positive 2, 7 times a negative 3, right? And so that's going to give me positive 5 over 21. That's even less than a half. So 5 over 21. So I'm like down here still. So maybe I plug in a negative 4 and see what happens. Let me erase some of this so I can continue my little table. Negative 4. So the negative 4 is going to give me a negative 11 over 1 times a negative 9. So that's really just going to give me 11/9, which is more than 1. It's 1 and 2/9. So when I'm here, I'm at 1 and 2/9. So it's still pretty low down there. So this is going to be pretty wide, I'm thinking. I'm going to plug in a 4 so I can see what happens there. So when I do that, that's going to give me a negative 3 over 9 times a negative 1. So 3/9, that's a little bit a nicer number, right? That's a third. So when I do that, I'm still pretty low down here. But it's eventually going to have to come up, oh, not so boxy. More curvy than boxy, but I'm not an artist by any means. So it's all flat and weird like that. The other thing is, you know, from the beginning when you kind of look at the asymptotes and everything, it kind of looks like maybe it's symmetric, but it's really not, because here I don't cross the asymptote, here I do. This comes way out before it shoots up, and then this is a little bit more curvy. So that's just all over kind of weird. All right, number 24. Factor this. This is going to give me x squared over x plus 1, x minus 1. So my domain is all real numbers except x cannot equal plus or minus 1. There are no holes. My roots are just at 0. My vertical asymptote, x equals negative 1, and x equals 1. So then tangency and togetherness here, I've got some. Because in the numerator, I have a factor that has an even exponent. So in the numerator, that means I have some tangency. And my tangency happens at x equals 0. In the denominator, I do not have a factor that has an even exponent, so there is no togetherness. In behavior, these are tied in degree, which means that I take the ratio, so this is just y equals 1, which means there are no slant asymptotes. And then my y-intercept, since my root is 0, it is 0, 0. My number line, I'm going to put on there my root, which is at 0, and my asymptotes. So I have 0, and then I have my negative 1, and my positive 1. So if I plug in a negative 2, numerator is going to be positive no matter what because it's being squared. But then a negative 2 would give me negative, negative, so overall that's positive. If I plug in a negative 1/2, again, numerator is positive no matter what. Negative 1/2 would make this positive, negative. Positive 1/2, positive, positive, negative, negative. And then a 2 would be positive, positive, positive. So notice that this one did not alternate back and forth. Alrighty, so then to graph. Start with any asymptotes that I have. So I always like to do my vertical ones first. And also notice that everything I do in the exact same order. I mean, obviously the blanks are in the order that they're in, but I come over here, do my vertical asymptote, then horizontal or slant, and then I plot my points, and then I look for other points. Like, the more consistent you are in your process, the better all of this will be for you. So I have negative 1, and 1. Good enough. And then my horizontal is at y equals 1. Then I come over and plot any points that I have. I have a root at 0, and my y-intercept is at 0, and then that's all I got. So I need some other points. I always like to do the one like right on the other side of my asymptotes if I can. So x, y, and then I'll try a negative 2. So if I plug in a negative 2 squared is going to give me 4. Then negative 2 plus 1 is negative 1 times negative 2 minus 1 is negative 3. So that gives me a positive 4/3. So I'm at negative 2, positive 4/3, which is just 1 1/3. So it's about right there. Then I'll plug in a 2 over here. That's going to give me 4 in the numerator. Denominator, you give me a positive 3 times 1, so that's a positive 4/3 again. This one looks like maybe it is going to be symmetric. Again, that does not always happen. So let's see if I need any other points, because I really should, well, as long as I just have one point in each section, I should have an idea of what's happening, and that's really kind of what we want right now, is just to have an understanding of what is happening with them. And I look at my sign chart here. From negative infinity all the way to negative 1, I'm positive the entire time, which means I am not crossing down under here. So I'm staying up here. It's a possibility I could still cross this asymptote, but I don't know that, and we're not going to worry about that. So the shape is going to look like this. So I'm going to come here, something like that. Now the middle is always where it kind of gets a little weird. So let's go on the other side first. I know that from positive 1 to infinity, I am positive the whole time. So it's got to come like this and from up here. So something like that. Now between my asymptotes, between negative 1 and 1, I'm negative the whole time. I have this root at 0, but I'm negative all the rest of the time. Because there is tangency here, which means I'm going to have a bounce. And so I start negative. I don't have togetherness, so since I'm coming up here, I have to start from down here. I'm going to come up, and I'm going to hit that 0. It's tangent, so I bounce and come back down like this. So then when you're done, you kind of reflect on what you have. Okay, I didn't have any togetherness, so everything's going in, you know, in an opposite direction on either side of the asymptote. All my stuff that's supposed to be positive and negative is actually positive and negative. I have the tangency where I need it. I have all my points plotted, and all that tells you the little bits and pieces of what you need. Okay, so that ends part 3.